warahmatullahi wabarakatuh. My name is Muhammad Izwa bin Cina Azman. Number metric 13 DEP 20F1024 with members of my group, that is Muhammad Irfan bin Muhammad Noor and Muhammad Afizuddin Afandi bin Noor Asarah. Today I want to present 3.8 application of integration. One very useful application of integration is finding the area and volume of curved figure that we typically get without using a calculus, since we already know that can use the integral to get the area between the x-axis and y-axis and a function. We can also get the volume of this figure by rotating the figure around either one of the axes. This is the picture shows about area and volume of bounded region and the formula for x-axis and y-axis. Formula for x-axis: area equal to integrate a to b y dx. For volume, integrate a to b pi y square dx. For y-axis, area integrate a to b x dy. Volume integrate a to b pi x square dy. Area between curves. Since we know how to get the area under a curve here in the definite integrals section, we can also get the area between two curves by subtracting the bottom curve from the top curve everywhere where the top curve is higher than the bottom curve. The cool thing about this is it even works if one of the curves is below the x-axis, as long as the higher curve always stays above the lower curve in the integration interval. Note that we may need to find out where the two curves intersect and where they intersect the x-axis to get the limits of integration. And sometimes we have to divide up the integral if the function cross over each other in the integration interval. Here is the formal definition of the area between two curves. For function f and g, where fx greater than gx for all x in AB, the area of the region bounded by the graph and the vertical lines x equal to a and x equal to b is area equal to integrate a to b fx minus gx dx.
x4 plus 7, we need to change to use substitution to solve this question. So as you can see, x4 plus 7, you need to change a u substitution and that be u equal to x4 plus 7, and then you need to change to du to find our 4x3. That be du equal to 4x3 dx, and then dx you move to du, it be du per dx equal to 4x3. Then the answer is integration 4x3 dx per x4 plus 7. Then interpretation, du over u, du is, we pick at this line is 4x3 dx, which is u, we pick x4 plus 7. And then if we finish put this du over u, we need to put 1 over here because it is integration format. After we equal to 1 over u du, we need to change in absolute natural log in and we need to remove u, this u plus constant. And then finally after we move our u, it be in x4 plus 7 plus constant.
My name is Muhammad Afizuddin Afandi bin Noor Asara. Number metric 13 DAP 20F1033. Okay, my first question. What is area bounded by the curve y equal x cube x, okay, y equal x cube x negative 2 and x equal 1. Okay, solution this question, we can see from the graph, okay, that the portion between x equal negative 2 and x equal 0 is below the x-axis. Okay, so we need to take the absolute for that portion. Firstly, we elaborate x equal negative 2 and x equal 0 in formula area. Okay, formula area A. Okay, we elaborate this formula in formula, and kita will calculate result. And last, we calculate answer. Kame answer this question is 40.25 unit square. Is next question. I will explain question this. Firstly, what question 1? Find the volume the x-axis. Find the volume x-axis. This question 1. Okay, we know info for this question. Y equal x plus 1. Okay. Firstly, into x plus 1 in formula. Okay. Okay. 1, 2. Area this. Area. Y. X. Okay. Lastly, you calculate and comment this question. This question, this question is, this answer is 19 per 3 unit cube. And the next question and last question. We sketch the upper and lower bonding curve. Okay, uh, y equal s plus 1, y equal to s to square. The lower limit of integration is x 0. Okay. The lower limit of integration is s 0. Next, we need find where the curve is turgid. So we know the upper limit of integration equaling the two expressions of any solution. Okay. 2s s pindahkan 2s. So which y2 equal x plus 1 and y okay, y2 s1 and y2 x2. The volume required is given. We enter formula volume. Okay, so we enter formula volume pi 1 0 sorry 1 0 s sorry s. And you comment this question, and lastly you will get answer is 4 4 4.817 cm. Okay. Okay. Thank you for me.